Okay guys, this is still part of 3.2. So this is part B of 3.2 in your binder, and this is composition of functions. And so a lot of times we just call these composite functions. And what this means is we have a function inside of a function. And so there are two ways to write this. Now this first one is a circle. This is literally a circle. It is not a multiplication dot. So this says f circle g of x. Now, this gets super confusing in this notation, and we're still showing you this because it's still on the SAT, but what I would tell you when you see this is right away rewrite it to this, because this is going to help you. It makes a whole lot more sense. So this looks like it says fog here, f circle g. It is not times x. What you're saying is that you have this function. You're going to take this function g of x, and you're going to put it inside of f of x. So what we did in the first part of 3.2 is we had something that looked like this. And we said we take this function f, so let's just say we use this function f, and we're going to plug 2 in everywhere we see an x. So this would be 10 plus 2, which is 12. Now what this says is instead of taking a number and plugging it into f, I'm going to take g of x, which is this guy, and I'm going to plug g of x inside of f of x. So I would do the same thing we did on the first lesson, which is 5 parentheses plus 2. Now, what we did in the first part of the lesson is we just plugged 2 in. What we do in this lesson is we take this function of g of x, because that's what's on the inside of my parentheses, and I plug that in. So it would look something like this. And then I'm going to distribute and combine like terms. So if I see this, the first thing I'm going to do is f of g of 2. So first number, or first function is always on the outside, this is on the outside, and then this is the x value. So it looks like this. So we're going to break this into two parts. The first part is this, g of 2. Well, we just did this. We know how to do this from the last lesson. So if I want to find g of 2, I'm going to take my g function, and I'm going to plug in 2. So I have 3 times 2 minus 5, and this whole thing is 1. 6 minus 5 is 1. So now, what I'm going to do is I'm going to take this g of 2 and I'm going to substitute the value of 1 in for that. So now I have f of 1. So g went away, 2 went away. I solved g of 2. That equals 1. I'm going to plug 1 back into this function. So I have 5 times 1 plus 2. So this whole thing is going to equal 7. And that's my answer. Remember, if you don't have an x here, then you're going to have a number as your final answer. Okay, so this is already in function notation. So the first thing I want to find is f of 1. I'm working just like parentheses. I'm working from the inside out. So when I plug this in, I already know this is 7. I just did it. So now I want to find g of 7. So I take this f of 1. I'm going to substitute g. So g of 7 is going to be 21 minus 5. So 7 goes here, 3 times 7. So g of, actually it's not g of 7, it's the whole thing, is going to be 16. Okay? All right, you pause the video, you do the last one here, and then we'll move on. Okay, sorry about that. I gave you ones with big numbers. So h of 4, make sure you're using your h function. I get 48. 48, I had to go up here and figure out what that math was. Couldn't do that in my head. And so I get 242 as my final answer. Okay. So now let's go here. So this tends to jam people up, but it shouldn't. What this is saying is if I have an x, I'm going to end up with an x in my answer. So again, first thing I want to do is rewrite this in composite notation, function notation like this. I'm going to take my f function. I'm going to put parentheses in here. F function is my outside function, so I'm going to start with my outside function. Now, this is a little bit backwards, because up here what we did is we started with what was on the inside and simplified the inside and then took it to the outside function. Well, here, I can't simplify this anymore. It's already simplified. So g of x is just this guy. So I go straight to my outside function and I plug it in. So this gives me 15x minus 25 plus 2. So I would have 15x minus 23. Okay. These next two, it's the same thing. Go ahead and pause the video and do these next two and then come back. Okay, here's what we end up with. So Again, you start with your g function, you plug in f. Hopefully on C, you rewrote this as function notation first, like this. Okay, now let's go down here and look at it from a graph. So here's what we have. I have two different lines here, and what I would tell you so that it doesn't get confusing is I would highlight your lines. You can use the same color or only one or whatever you want to do. So I'm going to highlight my f of x function, and that's this guy, and it is this curvy function. So now I see a big difference between my two functions, okay? Now, what does this mean? So up above here, I had this circle notation, or I had this in composite notation, and it looked like this. This is different. Here I have an addition sign that's in the middle of it. So what this is saying is f of -1 plus g of -1. So we are not distributing this -1 to both of those. That's not what this is saying. What this is saying is I have this function f plus g, and x is -1 for both of these. So I could write this as f of x plus g of x. That's really what this is saying, but x is -1 in both cases. So I'm going to go up here to my graph, and I want to know what is the value on the f function when x equals -1. So I'm going to go to -1. I'm going to go to my f function. My f function is my highlighted function, so I'm going to go down, and the y value here becomes -2. Okay, now I go to -1, and I want to know what my g value is. Well, that's my non-highlighted function, so I'm going to go up, and that's going to be a +1. And then I just do the math. Okay, now this guy does not have a circle in the middle of it, so it is not f of g of 4. This is f of 4 times g of 4. So if I had something like 3x, we know that this is the same as 3 times x. So when I see these two variables next to each other, I know that they're multiplied. So here's what I have. So f of 4, I go to 4. I want to see what f is. F is my highlighted function, so I'm going to go up here, and my y value is 3. Then I go back to x equals 4. G is my non-highlighted function, so it's right here. It's 1. So 3 times 1 is just 3. Okay. Let's see. I think you can try these on your own. It's very similar to everything we did on the other side. So I would tell you to highlight one of your functions, go ahead and pause it and try it, and then come back. Okay, here we go. So I'm subtracting here. So I needed to find the f of -2 and the g of -2. Be careful here because I'm subtracting. I have minus a -1. So I have +1. So that's why this is 0. Okay. Composite function here. So I'd want to do the inside first. So I need to find g of 6 on my graph. So if I go to g of 6, I go to my g line, I get -1. So then I go to my outside function, f of -1. I go over here to -1. I go to my f function, which is my highlighted function, and I get -2. You know, make sure you're pausing the video if you need to go through this a little more slowly. Okay, circle notation, I'm going to rewrite it right away to this guy, which means I need to find f of 4 first. So I go over here to x equals 4. I go to my f function, and I get 3. So now I want to go g of 3. So I go back to x equals 3, and I go to my g function, which tends to be the same point on either one, which is 2. Okay, last one. And I know this looks funky, but you start on the inside, so g of 0. So if I have 0, I go to my g function, that's 3. So now I have g of 3. So over here when x equals 3, I go up here, and I get 2. Okay, so pause this video, go back and rework this, and look at where my answers are, and see if you can make sure that you've got all the same answers if it didn't work out the same. Okay, So now we're going to do this next part on a calculator. So function value on the calculator. So what happens is I have this f of x function and this big long thing, and if I wanted to try to plug in -3, that would be just a lot of yucky math, okay? So we're going to do this on the calculator so that you don't have to retype all of these things. So what are we going to do? The first thing that we're going to do is remember f of x is the same as y. So we are going to say, we're going to go to the y equals on the calculator, and you're going to type in your function. And just go ahead and write this down first, and then we'll go back, okay? And then from a clear screen, you're going to hit alpha trace, so alpha trace on your calculator, and you're going to pick y1 because that's where we're going to type this in. Actually, I'm going to go up here and add a 1. So we're going to put y1. And then when we have y1, we're going to put the parentheses and we're going to put whatever our value is that we want. Okay? All right, so let's do this together. So, all right, so here's my calculator. So step 1 is we're going to go into y equals and type in our function. So y equals is this button that's right up here on your calculator. So you can hit y equals, and I'm going to type in this function. So I have 5x to the 4th. So 5x, to get to the 4th power, you're going to use this caret button right here, which is the one right above division. Don't do squared and then back up. Just hit caret, put you up in the sky like that. Gives you an exponent, so you put 4. Now, it's going to keep typing as an exponent. So what I want to do is I want to use this arrow button right here to get out of it. And then I would have minus 13x. I'm going to go back up to caret cubed. Okay, sorry there's a glare, y'all. My light's giving us a glare. So here's my function. All right, so next thing I'm going to do is going to clear my screen. So clear your screen, you're going to hit second mode, which is quit, and I go back to a blank screen. And now I'm going to hit alpha trace. So alpha trace, and this little thing pops up. Now I can get there other ways. I can get there from bars, I can get there from other things, but alpha trace pops this up. Now I typed my function right here in y1. I could have typed it in any of these, doesn't matter. I typed it in y1, so when I get to alpha trace, I'm going to pick y1. Now I want to tell it what to run. Well, here I want to run the function when x equals -3. So I'm going to put parentheses, I'm going to do -3, make sure you're using negative and not subtraction, and I'm going to hit enter. And it tells me that my value of that function is 814. And that's my answer. I'm done. Now, what's nice about this is I don't have to retype the whole thing and change it for number 2 and put a 5 in. I'm going to just do the same thing. Alpha trace, y1, parentheses, I want to plug in 5. And so my value now is 1670. And if you're super lazy, what I can do on this next one is I can just go up here and hit alpha. I used my arrow button and I captured this, so I got highlighted what I wanted, and then I hit enter. And when I hit enter, it just repeats, and I'm just going to go over here and I'm going to type in 7. Okay, and then my last one is 1.25, so I'm going to go up here, capture this, and I'm going to go 1.25, and this gives me negative 7.246. Okay, that's it for this. Hopefully composite functions made sense.